Hi guys, this is a calculus video, Calc natural log equations video. And this one you want to watch before doing the partner problems 7.26 through 7.30. And you don't have to take notes on this. You can if you want, but if you want to just watch, that's also okay. So the directions are as follows. Given the general solution to a differential equation, find the particular solution, y equals f of x, with the initial condition. So a lot of times when you're solving a differential equation, so dy dx equals something else, or you separate the variables, you take the antiderivative, and very often you will end up with something like this, okay? This is the general solution because we have c right there, which could stand for any number. This initial condition will allow us to get the particular solution. There's only one value of c for which this initial condition will work out. So, okay, and a lot of times, guys, on the short answer sections of the AP Calc exam, if they say to find the particular solution y equals f of x, here they're telling you to solve for y. All right, that's what they're telling you to do there, is to solve for y. They want it in this form. So finding c and then rewriting it in this form with that c plugged back in, that would not be what they're asking for. They want a particular solution to be in this form here. Okay, so I'm just going to go through this relatively fast. All right, so natural log is log base e. So this is log base e of absolute value of y equals this. Converting to exponential form, this is in logarithmic form, so first I'm going to convert to exponential form. So this is e to the x to the third plus 8 plus c equals the absolute value of y. Okay, so I just some of you say this, if this isn't familiar, don't worry about it, but you roll up the log. Okay, so I'm just going to switch sides here. So this is the absolute value of y is equal to, oh, and while I switch sides, guys, I'm going to make this observation. If I group those together, if I want to split up a base that's raised to an exponent, and that exponent is a sum of things, I'm going to use this law in reverse. Okay, so actually, so let me say this actually off to the side. Okay, so off to the side, I'll just remind you of this rule. Okay, x to the a times x to the b equals x to the a plus b. And you could also use this law of exponents backwards. If you have a base raised to a sum, you could split it up like that. So I'm going to split this up. So this is e to the x to the third plus 8 times e to the c. Okay, where c is some constant. All right, so we've got absolute value of y equals, I'm just going to rewrite this, e to the c times e to the x to the third plus 8. So this is the absolute value of y. I want just y by itself. So y could be the positive or negative value of this. E to the c times e to the x to the third plus 8. Okay, now the next thing that you're going to do is, so I'm going to move up here. I'm going to introduce another, I'm going to let e to the c be something else. So now this is going to be y is equal to, let's do k. You could do any letter. K times e to the x to the third plus 8. But then I have to tell my reader what k is, where k is equal to plus or minus e to the c. The k is just easier to work with than e to the c. So I'm just doing a substitution there. Okay, now I'm going to use this particular solution to figure out what k is, and then I will be able to plug it back in and I'll have this is not the particular solution, initial condition. I can use this initial condition to figure out what k is, and then I will have the particular solution. All right, so xy, so 5 equals k e to the negative 2 to the third plus 8. This ends up to be negative 8 plus 8, so this will be to the 0 power. Okay, so that right there is 0. So 5 equals k. So the particular solution is y equals 5e to the x to the third plus 8. Okay? Let's do another one. And then your partner problems today are just a series of problems just like this so that you can get the hang of that. Okay, now here is this next one. Okay, so just like before, you're going to start off by converting this to exponential notation. So I have, and instead of writing it like this, I'm just going to write it immediately with my y's on the left side. So I have the absolute value of y plus 3 equals e to the 5x to the third plus c. All right, now I'm going to split this up. So we've got the absolute value of y plus 3 equals e to the 5x to the third times e to the c. Okay. And then, so I'm just going to go a little bit faster. So now I'll drop the, I'm going to drop the absolute values, k e to the 5x to the third. And then I got to tell my reader what k is, where k is equal to plus or minus e to the c. So I skipped a few steps up here. Okay, so like I skipped this step. All right, which is fine. You don't have to skip it if you don't feel comfortable doing that. Okay, so I've got that y is equal to k times e to the 5x to the third minus 3. And then we've got to figure out what k is, and then we'll have the particular solution. So this is the initial condition that we're given. So that'll go in for x, that'll go in for y. So we have negative 6 is equal to k e to the 0 minus 3. And e to the 0 is just 1. So you get that k is equal to negative 3. And then you will get the particular solution is y equals negative 3e to the 5x to the third minus 3. Okay, guys, so there's that. And so, yeah, you're just going to do a problem set that is very similar, and that will be partner problems 7.26 to 7.30. Alrighty, see you soon. Bye-bye.